Next, I want to extrude the volume, not like that, but going that way. Because eventually we're going to take this and Boolean that against our grid plane. So for the depth, let's say negative 0.05 for right now. Maybe a bit more than that, actually. Let's say negative 0.25. Okay, and then we need to convert this into a volume so that we can reconvert it into geometry. The reason why I'm doing that is because I want to change all the topology on these shapes. So I want to eventually add a little bit of detail, and I need to change the topology. So VDB from polygons, voxel size 0.005, maybe a little bit less than that actually, 0.002, maybe even lower than that, 1. Okay, so once we have something very detailed like that, let's actually go a little bit more coarse. Okay, now we can convert this. So convert VDB. And I want to convert that to polygons. Now I'm not going to use this additivity quite yet because that additivity actually creates problems along the edges. So I'm going to leave that alone for a second and instead rely on the poly reduce SOP. And I'm also going to change this to manual before it tries to cook because it'll freeze it up. But on that poly reduce, let's take our output polygon count and set that to 100,000, like so. And also let's try to equalize these lengths by just turning that up a little bit. Let's refresh this and see what happens. Okay, and just to save us a little bit of time, I found that 300,000 gave us the resolution that was good. And in this case, I just turned up the equalized lengths a bit more so that we have something that looks right about there. Now at this point, I want to add some detail. So instead of using the mountain SOP, let's actually use the attrib noise SOP right here. And I like what this does because it gives us more control, honestly. The key to this, though, is to change that attribute name to P so that we're altering the position of the points, and then the range values here to 0 centered values. It looks super crazy, but if we turn that down and we go to our amplitude, let's say 0.001 for right now, and turn down this element size. Let's actually turn this up a bit more. There we go. Element size, we bring that down to, let's say, right around here or so, and change the noise type to Whirly Cellular F1. This gives us a really cool, rocky looking noise. We actually want to probably take this amplitude down a bit more, 0.00, or actually 0.01, I think is what we want. And there we go. I think something like this will just add a little bit of visual breakup as we Boolean these shapes out. So now it's time to Boolean this out. Let's go ahead and use a Boolean shatter. We'll take our original grid, extrude volume on that as well, so that we have some volume. And then we're going to take our cutter pieces and move them over what we got here. S for select, R for rotates, hold down Control to snap that rotation, E for scale, maybe right about there, and then just use these handles to go outwards like that. Okay, so we want to just cover this whole thing, go beyond the boundaries just a little bit. It'll help with the Boolean. So I'm going to go a little bit further than I need to, maybe right about there. And now that we have this, let's also go ahead and go open the Y like that, and just be sure that you're covering the whole darn thing. Okay, there we go. We have this, we have that, and almost there. Trust me, you don't want to leave these non-manifold edges whenever it says this, because if you do that, it's probably going to create geometry that messes you up later on down the road. So to fix this, let's really quickly measure each one of these pieces and see if we can find any piece which is really, really small. A lot of times there's these tiny slivers of polygons that get in the Boolean stream that mess things up and cause this warning to happen. So to measure every single piece, we'll use the measure stop, and we'll set that up here before we hit the Boolean. And we also need to say that we want to accumulate per piece, so we need the class attributes. And to get that class attribute, connectivity. So just all kind of basic Houdini stuff thus far. Connectivity says class as a point, but let's change that to primitive. And then for the measure, we now have a measure thing for each one of these primitives. Now, if we go to our geo spreadsheet, let's see what we find over here. If we go to the area and we sort this by the smallest, look at that. There's this piece that's really, really small. Actually, a couple of them right here. And then it jumps up in value. So now all we need to say is if the area is less than, let's say, 1, then go ahead and just delete that whole piece. Set that to primitives, just to be sure that it hits the primitive attributes. And now if we go to our scene view, that should clean up really small pieces that might have somehow gotten through the cracks. Now if we take this and set it up with the Boolean, our problems should be solved. And now we are good to go. No errors or anything like that. Maybe we should actually clean this up. Why not? Let's just go like that and remove all attributes. And for right now, all groups, so that we just have clean geometry. Do an assemble, exploded view. Now we end up in a pretty good spot to continue everything from here. In the next video, let's talk about these tectonic plates and start getting them to do what we want them to do.